Good morning, good afternoon, and good evening, everybody. This is Miss Abney. I'm going to be going over Topic 1, Lesson 1-6, Linear Systems, in these next series of videos. In this lesson, we're going to see how you can find and represent solutions of systems of linear equations and inequalities. Key terms here. Basically, we're going to be looking at different types of matrices, dimensions, inconsistent systems, the solution of a system of linear equation, and basically what a system of equations is, and a system of inequalities. By the end of this, you can use a variety of tools to solve the system of linear equations and inequalities. So in these ones, we're going to be solving them kind of by hand or looking at a graph. And then on 1-7, we're going to be using technology to solve these things. So let's jump right into this lesson. Let me move myself to the other corner so I could hit this next button. Let it load. Okay. So explore and reason. The graph shows two lines that intersect at one point. So here are there's my blue line and my orange line. What are the approximate coordinates of the points of intersection? So we're going to look here, right here at this point. And so I'm going to, it's not really on the lines here. So what I'm going to do is I'm going to just kind of look at where they intersect. Pull this in a little bit so I could get my line tool. Bring this over. And again, we're looking at an approximate. So I'm going to say this is approximately at, let's see, x being, this is 3. I'm going to say 3.1. And y being approximately 4.5. All right. And because this is an approximate, just put it in point form. So again, point form, you're going to have your x value and then your y value for point form. And when we're talking about solutions, now we're looking at solving both x and y. So when these lines intersect, this is where they both have the same y and x values. Okay, how could you verify whether the coordinates you estimated are in fact the solution? Is the point the solution to the equation of both lines? Well, we could do it by just looking, and this is kind of a general, this is an approximation. And we could also do it by substituting the value into an equation for both lines. Well, we don't have the equation quite yet, but we can find the equation of lines by looking at their slope and the point of intersection. So yes, the coordinates can be verified. Let me move this out of the way so I could type. So you guys could type this in your notes as well. Can be verified by substitution into the equations of each line. And when we substitute it into those equations of each line, what we're looking for is we're going to substitute the x value in, and we're going to see if our y values compare, if our y values are the same. We don't have the equation right now. We could produce an equation from the line, but they're just asking if we can verify. So we can verify this by substituting x into the equations and seeing what our y solution is. Mark where the lines are in. So now another thing here is, that's supposed to say yes, not y. Yes. Another thing here that we're looking at is that the solution to this equation, which basically means if let's say I had m1x plus b1. We're looking for the solution. We're looking to solve the x value here. And if the solution is correct, this is y1. y1 should equal y2. So if this is correct, then that point is when we satisfy our equation. That's when we have found an x value that makes this equation true. And that's what this is saying here. So that intersection point is a solution to the equation. So make sense and persevere. Use your results to refine your approximation and try again. Can you find the point of intersection this way? Is there a more efficient way? So is there a more efficient way than putting it algebraically? Because what we're doing now is we're looking at it algebraically. And algebraically is an actual very efficient way because you get to actually put the numbers in and test out the outputs that these graphs truly have. So if I were to come up with the line, clean this up a little. Okay, I'm going to do the blue line first. So I'm going to get blue here. And I'm going to do point slope form. So I'm going to pick the y-intercept. So we're going to have y minus 0, because that's where it hits here on the y, equals my slope. So let me see. Let me pick this point here. And another point here. So we go over 2, up 1. So my slope is going to be 1/2 x minus, oh wait, you know what, I did this backwards. Y minus 3 and x minus 0, because this is when x is equal to 0. All right, so this is point slope. You're going to do y minus y value on your graph. It could be any value, slope, x minus x value. And that's what I did here. Now I'm going to distribute that, so I get y equals 1/2 x. Oh, I'm adding 3 to the other side as well. 1/2 times 0 is 0, so this is plus 3. So here's my equation for the blue line. The orange line, get an orange here. Again, I'm going to do that point slope. I'm going to get this point here because that looks like it's on a definite point. So I'm going to do y minus my y value here, which is 1, equals my slope. So right, I'm just looking to see if there's a place here. So that's over 2, 1, 2, 3, 4, 5, 6. So that's 6 divided by 2, and I could clean that up into 3. X minus my x value here, which is 2. Okay, so this is going to be y minus 1 equals 3x minus 2. Add 1 to each side and distribute the 3. So I'm doing 2 steps in 1 here. 3 times x is 3x. 3 times negative 2 is going to be negative 6 plus 1. So you get y equals 3x minus 5. All right, so I have my 2 equations. If I were to take my 2 equations and set them equal to each other, and a great thing is since we haven't been really solving for x quite yet, since we haven't been doing this algebraically, I would suggest practicing your technology and putting this into your calculator or Desmos and solving for x that way. I don't know, every time I do algebra 5, 6, 7, I like completing these problems. So I'm going to subtract 1/2. And I get a equals, what is that, 6 halves minus 1/2. That equals 5 halves. So that's 16 divided by 5. There's 3.2. Oh, sorry, I don't need to put that. Oh yeah, 16, because 2 times that's 16. So I get 3.2 equals x, and then I could plug that, I could substitute that back into one of these equations and find my y. So we were a little bit off. I said 3.1, we came out with 3.2 here. But yes, you can do this algebraically. We have not covered algebraically, so don't worry too much at this very moment about this. But this is just an example of how you can do it algebraically. And so this one is, can you find the point of intersection this way? And is there a more efficient way? So the answer here is yes, you can find it. We did find the point of intersection this way. And the answer could be obtained this way as long as the coordinates are rational. Oh, that's another vocab word that they haven't given you. And solving algebraically might be more efficient. So rational means that, let's go back to the rational. Rational means that we don't have any imaginary values. We don't have any imaginary solutions. And imaginary solutions come in that kind of like fancy eye, like this. And we have not been introduced to imaginaries yet. So right now, all our solutions will be rational, which means they are a number between negative infinity and infinity. And then pi is irrational. Pi is another number that's irrational because it just never ends. So it's a definite number. You can put it in a ratio or a fraction. And as long as you have something that you could put in a fraction, even if it's 3/1, that is a rational number, and you could solve problems this way. Solving algebraically might be more efficient in some cases. Some cases, if you look at the graph and this point actually goes through a nice grid line, that would probably be more efficient because you could just look at it and get the numbers. So it all depends on the type of problem. On this type of problem, algebraically would be more efficient. All right, so if you have any questions, please ask me in your comments on Classroom, and we will be doing example 1 next.